to you guys today. I believe we all had a great night. Thank you for joining today's class. Today, we are going to be looking at an interesting topic: inter-VLAN routing. Inter-VLAN routing. It is very interesting, and we're going to be doing a lot of lab activities, a lot of packet tracer activities. I'll be happy if we can follow. For those who would have challenge, feel free to let us know. Okay, inter-VLAN routing. Now, the previous class we were able to understand what a VLAN is, and we understood that it is a virtual local area network. And we saw how to create this network, because you can segment your entire network by creating VLANs. So if I segment my network, I create different segments, different groups. Those particular segments are independent of each other. So I have guest VLAN, I have student VLAN, I have staff VLAN, I have finance VLAN, I have, so each of those groups or each of those VLANs are independent of each other. And so the people in a particular VLAN, probably the systems in maybe guest VLAN, do not have access to systems or devices in maybe students VLAN. So it's a way to logically segment your network so that you would have efficient management, you would have efficient security, you would have central network administration. You would be able to give account of your network and troubleshoot and manage it most effectively. Now, today we are centering basically on how do you make devices on a separate VLAN communicate with other devices on another VLAN. I have 2-3 VLANs, for instance, and I want to get devices on VLAN 10 to talk to devices on VLAN 20, or to talk to devices on VLAN 30. Okay, so how do you do inter-VLAN operations? So today's class basically is centering on this, and we have like different types of this inter-VLAN routing or movement, and then we'll look at them. The first one is the router on a stick. All right, we're going to look at it. We're going to first of all look at the routing operations, inter-VLAN routing operations. Then we'll look at router on a stick, and then we'll look at inter-VLAN routing on layer 3 switches. Then we'll look at how to troubleshoot inter-VLAN routing. So let's get to it. Now, what is inter-VLAN routing? VLANs are used to segment switch layer 2 networks for a variety of reasons. Regardless of the reasons, host on one VLAN cannot communicate with host on another VLAN unless there is a router, a layer 3 switch to provide the routing services. Remember, a router is an inter-network device that does what? Path determination, and then what? Packet forwarding. So it determines the best path. So a router receives traffic from this network, and then it can tell you where to forward it to in order to reach its destination. Now, inter-VLAN routing is the process of forwarding network traffic from one VLAN to another. There are 3 main inter-VLAN routing options, of which we are going to be looking at today. The first one is called the legacy inter-VLAN routing. This is a legacy solution. It does not scale well. Okay, we'll find out why. Then we have router on a stick. This is an acceptable solution for small to medium-sized network. Okay, that's router on a stick. Then we'll understand why is it called router on a stick. Then layer 3 switch using switch virtual interfaces. This is the most scalable solution for medium to large organizations. Wow. So these are the 3 that we are going to be looking at. I'm so excited about it, and I believe you should be excited as well. Okay. Now, legacy inter-VLAN routing. The first inter-VLAN routing solution relied on using a router with multiple Ethernet interfaces. Each router interface was connected to a switch port in different VLANs. The router interface serves as the default gateway to the local host on the subnet. Legacy inter-VLAN routing using physical interface works, but it has a significant limitation. It is not reasonably scalable because routers have a limited number of physical interfaces, requiring one physical router interface per VLAN quickly exhausts the physical interface capacity of a router. Now, what are we talking about? That we want to have VLANs communicate amongst themselves. And to do that, we need a router. Now, we have a switch where all these VLANs have been created. Now, legacy routing is saying, if I'm going to have 3 VLANs, for instance, it means that I am going to have 3 physical cables connected to a router. Okay, I was just looking for. Well, you're going to have 3 physical cables connected to a router. Just a minute. Okay. I have. I don't know whether you can see it, but I have a switch here. Okay. I have this switch here. This is this switch that has 24 ports. Okay. And then I have a router here. All right. Now, assuming I want to do legacy routing, what I'm saying is that for every port in the switch, for every VLAN that I have, I would have to plug in, maybe assuming I want to create 3 VLANs. So I am going to, let's say, I'm going to put 1 VLAN in this port. Okay. Then I would have to bring it to the router and connect it to a port on the router. Okay. If I want to have another VLAN, then I'm going to pick in another physical cable, assuming I'm going to put it, let's say, in this port. Okay, putting it here. Then I will bring it to the router and look for another physical interface and plug it in like this. Then if I want to have another VLAN again, okay, then I would have to bring the cable, then maybe plug it to another port, then come to the router, and then plug it here. Where is it? Very good. Now, you see, with this kind of setup, I am trying to say that I need to be able to have the number of ports on the router that will correspond to the VLAN, that the number of VLANs that I am creating. Okay? The number of VLANs that I'm creating, I need to have an equivalent number of ports on the router. So if I am going to create 20 VLANs, for instance, it means that on my router, I need to have how many ports? 20 ports. Okay? Now, or 20 interfaces. Now, the difficulty in legacy routing, because we are saying, you see, I had to put in a physical cable from the switch to the router, to the switch to the router. So anytime I am creating a particular VLAN, I must make sure that there is a physical interface that is going to receive it on the router. And that is why we said legacy routing is not scalable. Okay, like you see on this topology here, this is the router here, and this is the switch. So if I want to have VLAN 20, I must have a physical link that connects it to the router and the switch. and I have VLAN 10, I must have a physical cable that connects the two of them. So the more VLANs I have, the more cables that I connect physically to the router. Now, that is the concept of legacy routing. How about router on a stick? Oh, yeah. Now, router on a stick, we said the router on a stick inter-VLAN routing method overcomes the limitation of legacy inter-VLAN routing. It only requires one physical Ethernet interface to route traffic between multiple VLANs on the network. Okay? A Cisco iOS router Ethernet interface is configured as an 802.1q trunk and connected to a trunk port on a layer 2 switch. Specifically, the router interface is configured using sub-interfaces to identify routable VLANs. The configured sub-interfaces are software-based virtual interfaces. Each is associated with a single physical interface. Sub-interfaces are configured in a software on a router. Each sub-interface is independently configured with an IP address and VLAN assignment. Sub-interfaces are configured for different subnets that correspond to their VLAN assignment. This facilitates logical routing. When VLAN tag traffic enters the router interface, it is forwarded to the VLAN sub-interface. After a routing decision is made, based on the destination IP of the IP network address, the router determines the exit interface for that traffic. If the exit interface is configured as an 802.1q sub-interface, the data frames are VLAN tagged with a new VLAN and sent back to the physical interface. So, what are we saying in the router on a stick? We are saying that all you need is one physical interface on your router. And that one physical interface on your router, basically, you just need to configure sub-interfaces. And these sub-interfaces are logical. Okay? They are logical, they are not physical. So if I have one physical interface, within that physical interface, I can have as many as possible of the sub-interfaces that I wish to have. Okay? And that is why we said it overcomes the concept of legacy routing. So you see, legacy routing requires a router, but requires that router to be physically connected to the switch for each VLAN. Router on the stick on the other side also requires a router. It requires a router, but all you need is one physical router and then multiple sub-interfaces on that particular physical router. Now, the third method is called the inter-VLAN routing on a layer 3 switch. Now, why do we call it a layer 3 switch? And that's a question that some persons might want to ask. Because ordinarily, a switch functions at layer 2 because it deals with frames, it deals with MAC addresses. It doesn't deal with routing per se. That's a switch by default. But a layer 3 switch is a switch that has the routing capability. Because in our OSI model, layer 3 deals with what? It deals with routing. All right? Deals with basically routing. You have a packet that comes in and then it's going somewhere. It comes through ingress, it's going through egress, and you need to determine how it goes. Okay? Now, layer 3 switch basically has that capability. You need to enable that particular feature. Once you enable that feature, then it can perform the function of picking traffic from a particular VLAN and routing it to another VLAN. Okay? It picks from a particular VLAN and then routes it to another VLAN. And that's a very, very wonderful idea. So the modern method of performing inter-VLAN routing is to use what? Layer 3 switches. and switch virtual interfaces. A switch virtual interface is a virtual interface that is configured on a layer 3 switch as shown in this diagram here. Okay, so a layer 3 switch is also called a multi-layer switch, which operates at layer 2 and layer 3. All right, so you see I have this is a layer 2 switch connected to my VLAN 10, another layer 2 switch connected to VLAN 20. They are all connected to a layer 3 switch, which are both connected to VLAN 10 and 20. So you see, in this particular case, I don't need a router. The layer 3 switch is capable of performing these inter-VLAN routings for me. Okay, remember, we are talking about inter-VLAN routing. Are we together? We're not talking about like BGP, like border routing and things like that. Well, anyway, we'll come to talk about that very soon. So these are the three major areas. Now, the following are the advantages of this layer 3 switch inter-VLAN routing. One, they are much faster than router on a stick because everything is hardware switched and routed. Okay, that is one advantage. Number two, there is no need for external links from the switch to the router for routing. Because in case you don't know, when your traffic is moving across the network, the more routers it meets tells you the number of hops is going to meet, and that increases the latency. Or for instance, let me show you. Let me go to my command prompt, for instance. Let me show you guys. Okay, let me share this. All right, so I have this. So if I run ping to, let's say, cisco.com, okay, I am getting a reply, and within my reply, you see that I have the time allocated for my traffic to get to this IP address and back, and this is the time to leave, the TTL. Okay, now if I now do trace search cisco.com, now it will tell me the number of hops that will take my system to move from my traffic to move from my current system to Cisco. All right, so what it is telling me is that, okay, my traffic is moving from my network to my ISP, then to another router. This is one router, this is two routers, then this is three routers, this is four routers, then we have this, then we have this, another router, and then you see this is for each hop. All right, the tracer is going to be counting each of the hops as it keeps moving, and it will give me the IP addresses of each of those hops. All right, now the latency, or rather the time that it's taking my system, it's still moving, I am on 10. The time it's taking my system to get to its destination and back is dependent on the number of hops. So which means that the more routers that I have on my network, the higher the chances of my network latency. I don't know whether you get what I'm saying. The more routers that I have on my network, the higher the chances of latency. And that is why it's highly recommended that you run an inter-VLAN, a layer 3 switching. Okay, layer 3 switching inter-VLAN routing. All right, so you see it's taking me like 16 hops to get to cisco.com. Wow, that's a long distance compared to let's say Google or something like that. Okay, so the point we are making here is that there is no need for external links from the switch to the router for routing. So since everything is directly on the switch, then they are not limited to one link, because layer 2 Ether channels can be used as strong links between switches to increase bandwidth. Ether channel is saying, okay, if I am having a switch that, let's say fast Ethernet switches that runs 100 Mbps, I can configure Ether channel to say, okay, I will combine 2 or 3 fast Ethernet switches to give me 300 Mbps. Okay, that's the technology we are seeing here. So if I'm having gigabit switches, 1,000 Mbps, I can combine 3 of them to give me 2 gig of bandwidth. If my Ethernet interface is 10 gigabit ports, if I put in 2 or 3, you can imagine the capacity. So what we are saying here, the advantage with that is you can increase the capacity using the Ether channel. Latency is much lower because data does not need to leave the switch in order to be routed to a different network. That is just what I have just told you. So you don't need to now go to the router to make any decisions and stuff like that. It all happens here. The more commonly deployed in campus LAN than routers, which is true. All right, which is true. It's preferably in your campus LAN you run this kind of a network. The only disadvantage is that layer 3 switches are more expensive. Wow, they are more expensive, and I could not agree less. Okay, you check one for like, well, I don't know. You can Google it and find out, or go to eBay and find out, or Amazon and find out how much they cost. All right, router on a stick scenario. This is the scenario that we have. You see, I have router 1 here, then I have switch 1, switch 2. All right, now between these 2 switches, I have trunk links connected. All right, between this one and this router, I have a trunk link connected. All right, so what we are saying here is that I can create my VLANs here. I can create my VLANs here. But on this particular router, on this particular physical interface G0/0/1, I can create multiple sub-interfaces. You can see it here. G001.10, that's for sub-interface 10. 1.20 for sub-interface 20. 1.30 for interface VLAN 99. So you can create as many sub-interfaces as possible as you would want. So how do you do that? First of all, create and name your VLANs. All right, that's step 1. Step 2, create the management interface. We have done that in the last class. Then 3, configure your access ports. We have done that. Then 4, configure your trunking ports. So this is the first steps that you are going to be taking. Okay, so now the next thing is just a simple command to show us the VLAN configuration on switch 2. You enter VLAN 10, then you name it, then you exit. VLAN 20, name it, exit. VLAN 99, name it, exit. So we have created our VLANs. All right, very, very simple. The next stage is now interface. You give it an IP address, you know, shutdown. Then IP default gateway, you give it the IP address that you want. Now that's how to make it a management, configured management. Okay, then you come to this interface, you create as access. So we're going to do these packet tracers. We're going to do it together. So let's move on. All right, so on the router on a stick method requires you to create a sub interface for each VLAN to be routed. And it is highly recommended that when you are creating the sub interfaces, the number should match the VLAN number. Okay, but it's not mandatory, but just for documentation and easy troubleshooting. Okay, So each sub interface is then configured with two commands: encapsulation dot 1q, then your VLAN ID, then native. The native now is you're trying to tell it the native VLAN. Okay, then you now give it an IP address. These are the two commands that you would have to do that for each of the sub interface you configure on the router. Repeat the process for each VLAN to be routed. Each router sub interface must be assigned an IP address. All right. So we're going to do that, and let's see. So this is just the example of what we have talked about. So I go to my router, interface G001.10. That means this is sub interface for VLAN 10. Description, default gateway for VLAN 10. Okay, encapsulation.1q10. So you see this 10 here matches with the 10 here to tell me that I am doing this for VLAN what? VLAN 10. Then I give the IP address as the default gateway for that particular VLAN. Then I exit. I am done with this sub interface. I come with another sub interface. I come to .20. Description, default gateway for VLAN 20, encapsulation.1q20, the IP address, and exit. Okay, then I come to VLAN 99. Description, default gateway for VLAN 99, encapsulation.1q, IP address, this, and then I am done. All right. Now, these are for the sub interfaces that I have created. But that particular physical interface, all right, that particular physical interface, I have to create it as a trunk. All right. And that is why entering the interface, we said trunk link to switch 1. Are we together? So basically that is it. So we're going to do the activity, then we'll try it. These are the commands that we're going to be playing around with. Okay. Now, inter-VLAN routing using layer 3 switch. Inter-VLAN routing using the router on a stick method is simple to implement for a small to medium-sized organization. However, a large enterprise requires a faster, much more scalable method to provide inter-VLAN routing. So enterprise campus LAN use layer 3 switches to provide inter-VLAN routing. Layer 3 switches use hardware-based switching to achieve higher packet processing rates than routers. Layer 3 switches also are also commonly implemented in enterprise distribution layer. So what are the capabilities? It can route from one VLAN to another using a multiple switch virtual interfaces. All right, you can convert a layer 2 switch port to layer 3 interface, which is cool. We are going to do that. Then it can provide inter-VLAN routing. Layer 3 switches using switch virtual interfaces, all right, which are configured using the same interface VLAN ID. All right, so this is the scenario where you have your layer 3 switch, you have a PC, you don't need a router in this case. So all I do is configure my VLANs in here, and I am done. So there are 4 stages. 1, create the VLANs as we have done earlier on. We create the VLANs here in this switch. 2, create the switch virtual interface VLAN interfaces. The IP addresses configured will serve as the default gateways for hosts in the respective VLANs. Okay. 3, you configure access ports assigned to the appropriate ports. And then 4, enable IP routing. All right, issue the IP routing global configuration command to allow traffic to be exchanged between VLAN 10 and VLAN 20. Okay, this command must be configured to enable inter-VLAN routing on a layer 3. All right, so that is cool, and this is to verify it. So routing on a switch, if VLANs are to be reachable, by layer 3 devices, then they must be advertised using static or dynamic routing. To enable routing on layer 3 switch, a routed port must be configured. So a routed port is created on a layer 3 switch by disabling the switch port feature on a layer 2 port that is connected to another layer 3 device. Specifically, configuring the no switch port interface configuration command on a layer 2 port converts it into a layer 3 interface. Then the interface can be configured with an IP configuration to connect to a router or another layer 3 switch. All right, so this is the scenario that we're looking at. That in the figure, the previously configured multi-layer switch, that's this guy D1, is now connected to router 1, and D1 have both in an OSPF routing protocol domain. Assume Inter-VLANs have been successfully implemented on this D1 here. The G interface 001, which is this guy here, interface to the router, has also been configured and enabled. Additionally, router 1 is using OSPF to advertise its 2 networks, which is this network. Where is it? 10.10.10.0 network. Where is 10.10.10.0 network? Okay, look at it here. So this router 1 is advertising this 10.10.10.0 network and 10.10.20 networks. All right. So the point here is that if this system wants to reach this system, it doesn't need the router. It can come, because this is an Inter-VLAN, it can come here and come here. But once it is going outside of these VLANs that have been configured, then it needs the router to be able to take it to its area, to destination. So how do you do that? Configure the routed ports, use the no switch port command, enable routing, use the IP routing global configuration command, then configure routing using OSPF, then verify routing, and then verify connectivity. This is another activity. All right, so these are the activities we're going to do. All right, I think this is the last one. Then we do our packet tracer activities. How do you now troubleshoot? Troubleshooting has to do with step-by-step process of identifying a problem and resolving it. Okay, so when you have configured your router or your network for Inter-VLAN, what kind of problems are you expected to have, and how do you solve them? Now, the ability for a network administrator to use the show commands very well is what will help him become a very good administrator and to resolve his problems quickly. So there are a number of problems that you can have. For instance, you might have missing VLANs. All right, how do you know? First of all, you now do your show VLAN or show VLAN brief command that will show you the VLANs that are there. All right, so if you are having a problem with a particular VLAN, there is no traffic routing to those VLANs, or you cannot get details from there, then you start from here. All right, or you do show interfaces switch ports, or sometimes you can even ping. All right, the whole idea is you need to ensure that there is communication between your VLANs and their default gateways. All right, then another problem that people usually have is the switch trunk port issues. All right, you have configured a port as strong, or you have configured it as access port, or you have configured it as native. I mean, these are kind of confusing. And so a great number of times people tend to have problems with it. And so when you have that, first of all, you can use the show interface strong command to see what you have. And then, or you can do the show running configuration command to see what you have. Then another one is switch access ports issues. It's like what I said initially. Then finally, the router configuration issues. This sub-interface thing, a lot of people tend to have issues, especially when it comes to the encapsulation commands. All right, so that's that on that. So we have a lab on this. So we're going to look at this. These are all the lab that we're going to look at. And we are done. Okay, so let me share my packet tracer. And we start right away. Now, this first packet tracer activity is to configure router on a stick. Okay, we're configuring router on a stick. And remember the concept of router on a stick. You know, you have to create sub-interfaces on the router. Then you have to now do your encapsulation and then create this link as a trunk and then create your VLANs and you are good. So the activity says it has 3 parts. Part 1 says you add VLANs to a switch. 2, configure sub-interfaces. 3, test your inter-VLAN routing. So how do we go ahead? First of all, create your VLANs. So create VLAN 10 and VLAN 30 on switch 1. All right, VLAN 10 and VLAN 30 on switch 1. So I think we're not giving name to create, so we'll just configure it without name. So VLAN 10, all right, then VLAN, by default it will create the name itself, VLAN 30. All right, so we have done that, VLAN 10 and VLAN 30 on switch 1. Step 2 says assign VLAN to ports. What are we assigning? Assign the ports connected PC1 to VLAN 10 and PC3 to VLAN 30. So that is interface 6 and 11. All right, so 11, interface 11 is on VLAN 10, interface 6 is on VLAN 30. So how do we do that? We say interface F0/11. Switch port mode is what? Access. Then switch port access VLAN what? 10. That's port 11, right? I guess so. Yeah. Access VLAN 10. Then exit. Then interface F0/6. Then switch port mode is access. Switch port access VLAN what? 30. All right. So we have done that. So issue the show VLAN brief command to verify that we have done it. So this is what we are to verify, that VLAN 10 has port 11 and VLAN 30 has port 6. So let me widen this a bit. So show VLAN brief. Okay, so we are right. VLAN 10 has port 11, VLAN 30 has port 6. Now note, you see that it automatically gave it a name. When we created the VLANs, we didn't put names, but automatically it created a name for it. This is VLAN 30, and then it has been. So we're good here. Now we should ping PC1 to PC3. Were the ping successful? Why did we get this result? So we're to ping PC from PC1, ping PC3. Where's PC1? This is PC1. We're to ping PC3. What is the IP address of PC3? Let's check. PC3 is 172.168.30.10. So from PC1, we should ping PC3. So ping, paste it here. All right. So it seems not to be replying. It's timing out. It's timing out. All right. So obviously we are not getting a response. So the question is, why did we get this result? The result is because PC1 is on a different VLAN from PC3. and this interface have not been configured to move traffic between PC1 and PC3. So part 2 says configure sub interfaces. So we are to create sub interfaces on the router on the port G0/0. We are to create the sub interface and assign the IP address on the table here. Look at it, 172.170.10.1 for sub interface 10 and 30.1 for sub interface 30. All right, that's what we're gonna do now. So we come in here. Okay, set. So enable, configure terminal, then interface G0/0. Now I'm going to now create my sub interface, and to do that I say dot what? 10. Dot 10 will tell me I'm creating the sub interface. All right. The next thing I do, encapsulation dot 1Q, then what? 10. This 10 should correspond to the sub interface number that I am creating. Then I now give it an IP address. They said 172.170.10.1/24 would be 255.255.255.0, and then I am in. Okay, then we should do that for the other one. So interface G0/0 dot 30, right? Yeah, they say VLAN 10 and 30. So encapsulation dot 1Q, this one will be what? 30. Then IP address would be 172.17.30.1 255.255.255.0. Okay, so I've created the sub interfaces. Now they say we should verify, show IP interface brief command to verify the sub interfaces we have created. Okay, so all right, so show IP interface brief, and let's see what we've got here. All right, so you see I have a sub interface here, and look at it, administratively down. Then I have another sub interface here I've created, administratively down. Okay, all right, so we are okay. So they say we should enable the G00 interface and verify that the interfaces are active. So config T interface G0/0. Now I am talking about the physical interface. Now I will say no shutdown. So if I say no shutdown, look at the message I got. I got that line, the interface is up for sub interface G00.10 and then for .30. So because I enabled the physical interface, all those other ones came up. So what am I going to do now? Do show IP interface brief. So now you see initially they were administratively down, but look at it now. They are up. All right, they are up. Then the last thing we need to do, or well, I don't know, they said we need to configure the switch as a trunk. Where is the switch? This interface here, it needs to be a trunk. So configure terminal interface. What interface are we using? G0/1/1. Switch port mode is what? Trunk. All right. So the moment you configure it as trunk, that means it is able to carry the different VLAN information that moves across. So let's check our results and see what we have got. Check assessments. Okay, yeah, we got it. We have 60/60, 12/12. And we seem not to have made any mistake here today. All right, that's a good one. So the next packet tracer activity we are going to do, let me launch it. It's going to be layer 3 switching. All right, layer 3 switching. Okay, so this is what we have. So let's see the activity. Wow, this kind of loaded. It's really loaded indeed. Wow. All right, there's like kind of IP version 6 here also. All right, so let's give it a try, and let's try our best so that we can get it right. We're to configure in this activity layer 3 switching. Okay, that's where we have this multi-layer switch here. All right, this multi-layer switch. Layer 3 switching, we're to configure inter-VLAN routing. So our point is that we should have different VLANs so that we'll be able to be routed using here. Then
not receive on our end.
We should configure IP version 6 inter-VLAN routing as well. Okay. So in part 1, you will configure the gigabit Ethernet G0/2 port on this switch. All right, on the multi-layer switch as a routed port, and verify that you can ping another layer 3 that address. All right, so let's begin. Oh, okay. Sorry, you guys, I have not shared it. I'm so sorry. Oh, sorry. I'm sorry about that. What I was saying is that we have these switches here, and this is the multi-layer switch, and we are supposed to now have different VLANs here where we're going to route our traffic through this particular multi-layer switch. So the first instruction is that we are to create, configure this port as a routed port. All right, it says that on MLS, configure G0/2 as a routed port and assign an IP address according to the addressing table. This is the addressing table for MLS, and this is 0/2 here. So we're supposed to assign this IP address. Let me copy it. This IP address for IP version 4 and IP version 6 as well. Okay. So let's get into it. All right. Then this. Okay, configure terminal, then interface G0/2. That's the interface we're talking about. Now, remember we said if we want to make it a routed port, because that is the interface that will be doing the routing, we have to do the what? No switch port. All right, we have to issue the no switch port command. Then IP address, we copied it, paste it, and then 255.255. Okay, coming 255.255.255.252. It's a /30. All right, so we should verify connectivity. So they say verify connectivity by pinging this IP address. Okay, so let's ping it. Do ping. Right, let's see. Okay, yeah, we have a success. All right, once you see this, it means that it's a success. So we are good with A and B. Then part 2 says configure inter-VLAN routing. So we have to add these VLANs. This is add the VLANs to the multi-layer switch according to the table below. All right. Packet tracer scoring is case sensitive. So type the name exactly as shown. Okay. All right. So I think to make it easy, we'll just copy it. So we have to create these VLANs. Okay. So I'll say VLAN 10 name is what? Staff. Okay. Then let me copy this. Exit. VLAN 20 name is student. Okay. Then VLAN 30 here. VLAN 30 name is what do we have? Faculty. All right. So we have created our VLANs and we are supposed to assign IP addresses to the VLANs. Okay. Right. So what are the IP addresses? We are supposed to configure the IP addresses on the VLANs. Where are the VLANs IP addresses? Okay. Where are the IP addresses on the table? Sorry. Okay, look at it. So VLAN 10, this is the IP address. All right, so /24. So exit interface VLAN 10, then IP address is this 255.255.255.0. Okay, then I go to this one, VLAN 20, interface VLAN 20, then IP address, it's also /24 255.255.255.0. Okay, then I come to VLAN 30, VLAN 30, exit, interface VLAN 30, then IP address is going to be this 255.255.255.0. Now, there are other VLANs that I have not yet created. Maybe I will just go ahead and create, like VLAN 99. VLAN 99, this is the IP address. But we're not giving a name for VLAN 99. I hope we will not make a mistake. So let me just create it. If we make mistakes, we'll always correct. So VLAN 99. Okay. Then interface VLAN 99, IP address. What's the subnet mask? It's also /24 255.255.255.0. Okay. All right. So we have done that for the VLANs. We are also supposed to create IP version 6 addresses for them. Okay. So okay, we'll get there. Let's follow the instructions. So we have done this. Configure trunking on the multi-layer switch. All right. So we will go on this interface of multi-layer switch, and then we convert the port to trunk. All right. So there we go. Exit. So interface G0/1 Switch port mode is what? Trunk. Okay. Then switch port trunk native VLAN 99, because that's the management VLAN. Then what else are we asked to do? All right, so encapsulate the link with the .1q protocol. All right, so we'll now say switch port trunk encapsulation .1q. Okay. All right, so we're good with this. Now, before I leave this particular multi-layer switch, let me quickly create the IPv6 addresses on each of the VLANs. This is VLAN 10. So exit, so interface VLAN 10, IPv6 address, this, okay. Then come to VLAN 20, exit, interface VLAN 20, IPv6 address is going to be this, as just copy and paste. And then I come to VLAN 30, VLAN 30, I say interface VLAN 30, IPv6 address, and then here we go. Then I come to, still on the multi-layer switch, interface G0/2. All right, so exit interface G0/2, IPv6 address. All right, so what's the next thing to do? All right, switch port, where is it? Configure this. We have done this. We have done this. All right, okay, we should come to the switch. All right, configure trunking on switch 1. So we're done with this guy. We come to switch 1. All right, so we are configuring this port as what? As trunk. All right, so we now say enable configure terminal interface G0/1, right? Switch port mode is what? Trunk. All right, so configure the native VLAN on the trunk. All right, so what's the native VLAN? Switch port trunk native VLAN what? 99. Right, so we have done that. Then they say we should enable IP routing on the multi-layer switch. All right, so, and you enable IP routing on the global configuration mode. So I come here and then I only say IP routing, IP routing. Okay, so once I do that, we can issue the show IP route to be able to show us all the routes that are there. So let me expand this. Show IP routes. Now, if you observe, anytime I use the command do, I am using it outside the privilege executive mode. All right, because most of the show commands are expected to be run on the privilege mode. So instead of me to go back to the privilege mode and come back to the global configuration mode, I only just put the command do, then run the command, and it helps me run it. Okay, so look at it on the multi-layer switch. So it has given me my routes. I have a route to VLAN 10, I have a route to VLAN 20, I have a route to VLAN 30, I have a route to VLAN 99. Wow. So you see, I have all these routes that we're talking about. So, okay, so we'll configure IPv6 unicast routing since we have done the IP routing for IP version 4. So IPv6 unicast routing. Okay. Now we say we should test ping PC0 from PC0 ping PC3. All right, and verify. Where's PC0? PC0, we should ping PC3 and verify. What's the IP address of PC3? PC3 is this. So PC0 ping this. Wow, so I've gotten a reply. So how about my version 6? Let me ping the IP version 6. PC0 ping PC3. PC3 has IP version 6. Okay. So I will come from PC4. Where's PC4? PC4 ping this. Sorry. Good. So you see, we have a reply. All right. So it means that our work is correct. So let's check our results and see what we've got. Okay. Yep. We have 24/24, and that means we are correct. So I think it's good. Everything went fine today. Yeah. All right. Well, I want to encourage you guys to do your labs. We have a challenge, a challenge activity here. I'm going to upload it to. I'm going to upload it to the WhatsApp and to the Teams, and I expect you to do today. All right. I had wanted to do it, but I think it's good to give you guys a little something to chew. Okay, so let me just upload it for you guys now on the team. Let me see. Let me send it. Where is it? All right. Here. All right. There are two activities I want you guys to do: the troubleshooting activities and the Inter-VLAN challenge activity. So I just sent it to the team. Let me also send it to the WhatsApp group so that you guys will all have it. Just a moment. I've sent it to all of you, and I expect that you should do it today. Okay. Now we have finished chapter 4. Next class we'll be looking at chapter 5. But I want you guys to be able to do your. First of all, let me thank you so much for attending the class. You guys have done well. For those of you who have attended, thank you very much.